grant for ideas. NGSS was not quite in its full force. And we wrote this grant primarily to try and help you guys think about how do the practices, science and engineering from NGSS, and math practices from Common Core, how can we help you as elementary teachers not have to always feel like we have to be schizophrenic, but that in fact you can use those practices together to help kids deepen their learning. As this grant has matured, we've taken a deeper dive into what NGSS is about. And two of the shifts that I want to remind us about in NGSS is number one, the importance of connecting learning to the real world. I kid a lot about this. Think about baking soda and vinegar. How many of you use that in your real world anywhere? Most of you know. How many of you play with it in a science classroom? Yeah, the hands start to go up, right? So, yes, it's a phenomenon, but it's not really a real world phenomenon. It's a way in which we instruct people to learn that solids and liquids can make gases. What would be a much better phenomenon about chemical reactions that happens every day? Cooking, absolutely. Make a cake, isn't that pretty miraculous? You take eggs and flour and milk and somehow you get something that tastes really good. How did that happen, right? So that's a real world phenomenon. You might use smaller little ideas to help kids learn, but we're really trying to ground kids in understanding the world around them. And that's the importance of doing these phenomena. The second shift in NGSS that's really important is this whole idea of application of content. It's not just content for content's sake. It really is, again, to try and help them understand what's going on. So, I'm going to ask you to just watch this video and jot down questions as you see it going. All right, just jot down a couple of questions that you have. Just quickly jot them down.
So what time of the day is it?
All right, what time of day is it? Who else has a question?
Where exactly?
Okay, where is that going on? Another question. Yeah.
Are the fish scared?
Are the fish scared? Okay. Yeah.
What kind of fish?
What kind of fish?
Why are they jumping after the not before?
Okay, so well, one question is, are they jumping after, and then if they are, why? What did you guys think over here at this table?
I was wondering what kind of fish they were.
Okay, great. Uh-huh.
I just, my first one, why are they jumping? What are they doing?
Okay, why are they jumping? What are they doing? Huh?
Yeah, kind of like person fear. Is it a way of defending themselves?
Okay, does that have something to do with defense? Anything else that you thought? Uh-huh.
The motion of the water and the boat causing them to
Okay.
jump out of it. What's causing them?
What's causing them to jump? Is it the motor? Is it the waves themselves? Anything else?
Are they going upstream? Is it like salmon season?
Okay. So are they swimming upstream or downstream, or are they salmon, or anybody else? Yeah.
Do the people need to do that?
Okay. So I'm going to pause right here. You watch that video for all of about 10 seconds and look at the plethora of questions that you had about what's going on there. That's the power of a phenomenon. It's something that happens in our natural world, and it causes us to wonder about it. It causes us to ask questions like, what's going on here? We're going to give you another example of a phenomenon. Lucia, can I help? We're going to give you a set of cards at your table. We're going to ask you to take these cards and just read each one of them and see what sense you can make, what do you think is going on. So you're not taking them from an envelope, you're just going to undo the paper clip. What observations do you have and what questions do you have? And you have 10 minutes to ponder about that, and then we'll come see where you are. All right, we're going to bring your conversation to a close, and we're going to try and answer these questions. What's going on? Who's got an idea about what might be going on? What's the phenomenon? All right, there's some patterns going on. Who else has something to add to that in terms of what's going on? What was the pattern? So your observation is that there were more birds in the summer, and your inference is something was going on under your sheet. Is that it? All right. Anybody else have something that they noticed in the data or in the statements? Yeah.
Having lots of every dark. Hour.
Yeah.
Nothing else to do. Longer.
So an observation that when it gets dark, something's going on, and an inference is there's nothing else to do, right? Okay. Yeah.
I work with the opposite. When it's hot and I'm sweaty, I say, don't touch me.
Okay. So when it's cold, you're ready, right? When it's hot, you're not. All right. So you all noticed some kind of interesting pattern. This activity actually was developed, I don't know if you guys remember the Super Bowl ad this year, where they had all the kids that were in the different team shirts. Do you remember seeing that? And we were laughing about. So that's kind of interesting, all these kids that are born around Super Bowl time. And so can we find some phenomenon to do this? So this is actually a real phenomenon that started in January when we were watching that ad. So the question at the table, what I'd like you to talk for a second about is, what sciences do you need to know in order to figure out why that phenomenon is happening? So just discuss at your table topics in science you think you need to know, types of science you need to know in order to be able to discuss that. Okay, human anatomy would be helpful. What else?
Psychology.
Psychology. Okay, what else?
Anthropology.
Anthropology. Oh, interesting. Okay, what else? Kinesiology? Is that what you just said? I like kinesiology, actually. I don't like it. Ego. Psychology. All right, what else did you need to know?
Stress causers.
Wait, gotcha. Go ahead.
Math science is kind of a statistics, but I don't know if that's the math more than it is.
Okay, so math certainly could be in here. We gotta know how to count. We had another idea.
Data tracking.
Yeah.
Okay. And I heard somebody talk about physics. So what part of physics do I need to know? Okay, I'll let you just think about that. What about earth science? Anything from earth science? Yeah, the whole thing about this January routine and the summer routine, and when do we have summer and when do we have winter and those kinds of things. So here's the cool thing about a phenomenon. When you talk phenomenon-based science, you're automatically integrated. It's impossible to address any phenomenon and just be in one dimension of science. It's impossible, right? So that's a cool thing for us to know in general about phenomenon. As we talk about it with you all guys, we're going to ask you to take a phenomenon for your unit, and we're going to look primarily through the lens of physical science. But you, in fact, might choose a phenomenon that has other things going on, but we're going to look through that lens of physical science. So when we think about what a phenomenon is, we've already talked about this a lot, which is why I'm flipping through these slides really quickly. A phenomenon is simply a natural occurrence that happens in the world, and we can observe it, and it causes us to actually wonder about what's going on. Phenomena happen whether we're here or not. It is the way the world operates. Okay? But we in education say, okay, we want to know about that phenomenon, so we stick some criteria on what makes a phenomena important. So just remember over here, in the world, it rains whether we're here or not. The sun comes up and the sun goes down whether we're here or not. I was going to say babies are born whether we're here or not, but I guess that's not true. We could have some spontaneous generation going on along the way. The purpose is, the idea here most of all, is that phenomenon is how the natural world works. Why do you think we use that word natural? Okay, so I think what you might be saying is there's something called man-made as opposed to what naturally occurs. So interestingly in phenomenon, in our science framework, it's going to tell us that you can do both. Man-made, it's naturally occurring, or man-made, where somebody went out and built something, like a bridge in the Grand Canyon, that you can walk out and look down at the canyon below. Either one of those, but why natural? Well, let me ask the question another way. When you heard the word phenomenon, the first time you ever heard of it, what came to mind? So that would give us the two different things, natural and man-made, and for our purposes, in the California Science Framework, both of these are considered phenomena. Naturally occurring or something that I built are both going to be considered that. But did anybody ever think of the word phenomena in terms of Ghostbusters? Yeah, supernatural, right? Most people, when they hear the phenomenon, think it has something to do with voodoo, 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 and it's all that kind of supernatural stuff. So the word natural here is to help us understand that we're talking about the world as we know it and not supernatural kinds of things, right? The question becomes, if this is what the definition is, how do I have to think about it in my classroom? What am I trying to do? In the olden days, when we were teaching science, that means just before NGSS came in, science was all about knowing. In fact, every single standard we had said students will know something, right? In the NGSS world, it's all about figuring out stuff. So every time you think about your instruction, if you are simply helping kids to know something, that's the old way. Our job is to help them figure it out. So if we're going to help kids figure it out, we have to think about the phenomenon that we try and help them work with. So here's some criteria from an instructional point of view. It has to be relevant to kids. So some of you might remember when the astronaut came back just a couple of months ago, and he was 2 inches taller. Remember reading about that in the news? I was like, send me. I need to write you about it, right? I'll take it. But what was going on there? And in that moment in the news, it was a pretty cool thing that was going on, and middle school kids were pretty excited about that. It has to be something that connects things that we would not normally think of connecting. So if I was an 8th grade teacher, and I realize none of you are, but if I was an 8th grade teacher, I have to teach evolution and natural selection, and I also have to teach physical waves. It's like, how can I put that together? And so a phenomenon that we do have happening right now on our coast, even right outside of San Diego, is where they are tracking all of the white sharks to see where their breeding grounds are and to see how they move up and down the coast. So they're using wave technology in order to understand the shark population, and from that trying to figure out what's our impact on them. So a very nice place where you can take two ideas that seem so separate, natural selection and waves, and actually put them together in a phenomenon. The interesting thing about phenomena is it doesn't have to be phenomenal. So this is green grass with a brown spot in it, right? Nothing wowie-wowie about that, except why? Why in the middle of this big green field is there one brown spot? What happens to be going on? I want to pause here for a second about phenomenal. This morning you opened up with things that were all pretty phenomenal phenomena, right? They really kind of boggled your mind. And if you're like me and you're just getting ready to start trying phenomena, that's scary to me, because I don't know all that stuff up there. I don't know all these weird ideas. And when I Google the word phenomenon, I come up with all kinds of stuff and I have no idea what's going on there. So I don't want to do it. So I want to encourage you to not be phenomenal. Just think about everyday phenomena. Cooking, brown spots in the grass, the wind blowing, all of those, kids going down a slide, all of those are phenomena. So you don't have to be like, I can't get it. You can do something very simple, very concrete, something you're very comfortable with in order to engage kids in the conversation. You have a handout on your table. And if you'll pass it around, you'll find one sheet where it talks about criteria for a phenomena. Scan that list, just scan it for a moment, and stop on something that you found kind of interesting. So there's about 7, 8, 9 criteria. Take a moment to just scan it, find on, stop on something you find interesting. Second grade did that, right? It has to be developmentally appropriate. If I'm asking them to explain something and to figure it out, then it has to be something that happens in their everyday life. So fairy circles, as cool as they really are, is not something that's happening in San Diego. So I'm not gonna pick fairy circles. I've gotta find something closer to home. Obviously, kids have to be observant to observe it, because if they can't observe it, then they can't gather any data on it and make any kinds of explanations. And if I can answer it in one lesson, it's not a phenomenon, because it's more complex than that. That also means if I can Google it, it's not a phenomenon. Right? So for everybody goes, oh, I want to know the answer to that. You can find lots of answers and lots of definitions, but those are not phenomena. So that's too simplistic. It has to be a little bit more complex. And then, as we said, it doesn't have to be phenomenal. It just has to be something that intrigues kids and wants them to wonder and to ask questions about it. So as we work today, what we're going to be trying to do is to actually identify some phenomenon that will help guide the units that we've been working on. And one way that we're going to do that is to consider some ways to find the phenomenon. So one simply is, what's happening out and around in the environment that kids might care about, because a lot of environmental things are actually phenomenal problems that we can talk about and kids can actually figure out. You also can go to the national framework that talks a little bit about the DCIs and your grade band. You can use the resources that we just gave you that gave you some ideas about phenomena. You can also search phenomena on the internet, and you will find different sites that are trying to build databases of phenomena. In fact, you have one here in San Diego that John Spiegel has created, which is a very nice thing to try and think about the complexities of what phenomena are all about. So let's take a look at what this might look like in your classroom. Let's look at first grade, and the thing is, I have to teach sound, right? I have to do something about vibrating. Vibrations make sound. So a phenomenon that I could use is just the idea that when you pluck on a string or when you beat on a drum, it makes noise. So not earth-shattering, but something that kids in first grade certainly can do. The practice that I'm using is I want the kids to investigate what's going on when they do that plucking, and the science that's underlying it is that every time there's a vibration, I get sound, and sound happens every time something vibrates. So it's like, what's the intro for the kids to get into this, to get engaged and to get hooked, and, so it's not just a hook, and at the end, they can go back and explain what the phenomena was. So very different than the hooks that we used to use, like just to get them excited. This carries through the entire unit and go back and we do the explanation. Here's a third grade one, okay, and it's one on force and motion. The phenomenon is the idea about watching rockets. You could do a video where you're watching rockets. You could do stock rockets where they're out there building their own rockets and doing their own little liftoff, but what's going on? The idea here is that they would actually investigate some strong rockets, and it would be based on the idea that different forces cause motion to occur. So what you're looking again for is a tie-in between what the phenomena is, how do you want kids to learn about that phenomena, and what's the science concepts that's underlying it. Okay? I'm going to ask you to take a moment at your table and look at the list that we just gave you at your grade level. Okay, so turn to the page that's yours. And I'm going to tell you right now, this list was just generated and nobody edited it. So you're going to get a chance to edit. When you look at your grade level and you scan some of the ideas, you're looking for something that is observable, not a topic. You're looking for something that's observable, not a topic. And you're looking for something that's not a question, an observable event. So when you look at your list, talk amongst your table whether your lists are observable events. And if they're not, what would be the observable event?
Well, in kindergarten, we would also observe like just their energy. Talk about how do you feel before you eat, how do you feel after, how do you feel
So, yeah, so then you have to decide what grain size of eating is your phenomenon going to be about. Is it specifically when you eat a candy bar, what happens, and if you drink milk, what happens? That would be a smaller part of a bigger thing that says, my stomach's growling, I'm hungry, feed me. Anybody else? Who had bowling? Who had bowling in that grade level? What did you guys do with bowling? What did you decide? Is that a topic, a phenomenon, a question?
We didn't talk about it, it seemed like it actually have kind of multiple, areas, the whole, I don't know how to explain that, but it's actually multiple things.
So let's help Mary Beth with this and her team. So, bowling, if I say bowling, what did you observe? Anybody, what did you observe? Okay, so just, I'm a simple role, don't give me all the science, just what did I observe? The ball is moving, the ball's hitting the pins, something else. Okay, the pins are falling down in different patterns, what else did you observe? It slows, the ball seems to slow down, what else did you notice? Okay, somebody threw it, pro bowler seemed to put a spin on it, lots of things. All of those are phenomena, because it's what you observed. Bowling is a topic. It doesn't tell me what you observed. So in that situation, I could look at it from a bunch of different angles. No pun intended. Anybody else not sure about whether it's a topic or a phenomenon? You're always pushing yourself to say, what am I observing, when you're talking about the actual phenomenon. Moni, you have a question? So how would you turn the idea about there are conductors and insulators into a phenomenon?
What we came up with, which is just a piece, Michelle came up with it, that if you took two metals, one magnetic, one non-magnetic, and put them out there and let the kids try to figure out why they're both metal, and their misconception is that all metal is magnetic, and this one isn't, so why?
Yeah. So the thing I observe is that metals are like magnets, are attracted to some metals and not to other metals.
That brings me to my next question. Is it okay that we make our phenomenon only a piece about it? We're not dealing with wood versus metal and glass and rocks and soft, and we're not doing all of it in the same phenomenon. Can our phenomenon just be a piece to engage them and not be all of it?
And so that's the same question Michelle just asked me about, do I get to have more than one phenomenon along the way? So we'll go here to answer that question. All right. So you all know what your regular storyline looks like, right? Bunch of yellow post-its sitting on a thing, gives me an order, I start, here's my big idea, and on this graphic that I have there, that big thing is the biggest idea of this unit. These are sub-ideas, or sub-concepts, and these represent individual lessons. Okay, are we all right on that? And in our storyline, we know that when we want the kids to tell us a story back, imagine drawing a line here, and the kids are just reading back this very top part, because that's the conceptual story that you would want kids to tell you about what's going on. And they would be able to say, I know this, because I know these, I know this, I know all of that, and I know all of that. The idea of building a conceptual framework is that you have big hooks that they can put their understanding on, and that these bits and pieces connect. They all connect up, and those connect up to there. You're building like a closet, if you can't think of anything else, a coat hanger, in which they can hang all those little ideas. And that's what their conceptual storyline is all about. To this, we are now going to try and add a phenomenon. So when I get done talking in about 5 minutes, we're going to have you sit down at your table and look at your conceptual flow the way that you currently have it, and have you think about what is a big P and what is a little p. Now, we hate those words, but we're trying to find a way to make this really simple. So a big P is a phenomenon that may guide the entire unit, Whereas a little p might be something that just guides the subconcept. This would be the biggest idea, these would be sub-ideas, this would be the biggest phenomena, these would be little p phenomena. So what does that really mean? A big P might be something like the blacktop gets very hot on days when it's sunny. What am I observing? I'm observing that every time I go out on the blacktop when it's hot outside, that blacktop is really, really hot every time it's sunny. A much smaller P might be simply that if I put M&Ms out there on the blacktop, they're gonna melt really quickly. So the big P covers the entire unit. A small p governs just a smaller idea. Okay, so far? All right. So you can't see this drawing very well, but here's a phenomenon for those of you who are early on the early implementers and you're going to kindergarten next week to do that. This is the phenomenon that cadre is using. The phenomenon is simply that the wind blows in the afternoon. You all know that, right? You live in an area where it actually, if you're closer to the beach, you really, really recognize that. But when we look at that, that's the big P, but there are smaller P's. And in this diagram, they're called focus phenomena. That sun heats the earth. It heats the water, it heats the land, it heats the air. Those are three different ideas embedded in this whole idea about why the winds move and the idea that there's convection currents. So in this story, if a kid was saying why the winds blow in the afternoon, they have to understand that the sun heats the earth, but it does it differently. It heats the water different than the land, different than the air. And when that happens, convection currents occur, and it makes the winds blow. Okay? Good. Linda?
Can you help me again with our focus phenomena, a little piece of the big?
Little p. The big P on this one is winds blow in the afternoon. The little p's are each of these individual chunks. So if I go back to this story, the big P is winds blow in the afternoon. The little p's are the sun heats the earth, it heats the air, water, and land differently. Okay? Does that make sense? And the phenomena that I would have about it heating the land differently is what? What would be a phenomenon that would let kids know that it heats the land differently than water?
When I go to the beach, I walk on the sand and it burns my feet, and when I go in the water, I feel it burn.
Perfect. And that's an everyday experience, and if your kids have gone to the beach, they recognize that, right? But no problem. Or if they have a swimming pool in their backyard, the concrete's hot until I jump in the pool where it's cooler. Good. Right? So, any other questions on big P's and little p's and how that might contribute to your storyline? Are we okay on that part? All right. Then, your idea right now that we're going to do is we're actually going to stop talking, get a chance to get out your storylines, and think about some things that would go on there. What we're going to ask you to do is to brainstorm a phenomenon for your entire unit, something that you think would guide the whole instruction, and then for every sub-concept that you have, what might be phenomenon that would guide that. Again, use your resources. You'll have your person at your table to help you along in doing this. It's 10 o'clock. I'm going to suggest that we take a 10-minute break. We come back to your tables in 10 minutes, and at that point, we'll lay out your storylines. We'll know where you are. We have until 11:30 to work on this, and then we'll stop at 11:30, see where you are, and then go on to the next thing that we do, which is lunch.